So hello everyone, in this video we will extend our idea of regression over improving the accuracy score. So in linear regression we saw in our last machine learning video that on our given data points we try to do a best line fit, and that best line fit would be according to some calculations, according to some mathematical algorithms which is going to work. And so we also stated that it may be possible that a higher degree polynomial would be a better fit on our data plot than a simple line. So using an idea of a simple line, how we can extend it to polynomial regression also. In this video we will discuss that things. So it may be possible that instead of a best line fit, a higher degree curve can fit and improve our prediction accuracy. Suppose in a dataset which features x and y, we add a third column with features which stored x square values, and now we treat it as a multivariable linear regression with x1 equals to x and x2 equals to x square. So in our linear regression for n variables, we saw our equation would be y equals to m1x1 plus m2x2 plus c, where m1 m2 are basically the coefficients, and how to find out using few algorithms, mathematical algorithms using partial derivatives. We have talked about those in detail in linear regression. So we are basically applying a linear regression in 2D, and then we are substituting x1 equals to x and x2 equals to x square. Let our feature x2 be 2 times the feature x1. Then we clearly have a quadratic equation, right? So similarly, it may be possible that we are having more than 2 features. So like we have to take every NC2 combinations of those in those cases, right? So how we will take those, how we will code those, we will see in detail in this video. So remember, if we have n feature instead of x, we can create a bigger polynomial with NC2 more combinations, right? Two combinations if we make. And if we are stuck with applying a quadratic equation also, or we can go to higher dimensions, but as we will see, the applying of higher dimension has also some disadvantages, which is overfitting our model. So at first, let's just try to improve some amount of accuracy. So let's see how we'll do that in our diabetes dataset, and we'll see. So we first import the necessary libraries: NumPy, Pandas, Matplotlib, and scborn. And from sklearn we import datasets. From datasets we import Boston. So let's just see about Boston first. Now from sklearn we import our model selection, and we just basically split our data: x train, x test, y train, y test. So model selection dot train test split of xy. So we do the train test split, and you know already that if we don't provide any argument, third argument, so it is taken as 25% testing data and 75% training data. So you can see that is well divided, right? And also now we import linear regression basically, and we fit our model. So our object 1 contains the output which is done by linear regression, and we see that we got some accuracy score of 66%. Now we see what is our data frame basically, and we just Boston.feature names, we just change the name of our columns, and we see this is our data set. So if we see in this data set, we have more than one feature. We have a lot of features basically, and so there can be many combinations of NC2, right? So this is you can read more about this dataset by df.descr description basically. This is the crime rate, this is distance from Indus or something like that, age, distance, tax paying, and so we are basically trying to predict what will be our price of the house given that the crime rate in that area is something like this. So you can well understand that a place with high crime rate will have low price cost of the house, right? So those things are basically done in this Boston dataset. So what we do is, this is nothing, this I'm just testing this whether the multiplication of rows are working this way or not. So it works perfectly this way. So first we assign s equals to 1 for I in Boston dot feature names, and for j in Boston dot feature names. Basically we take two variables in two loops, and then we take a column s and increment every time, and for every I and j, so we iterate through all the feature names, and through every I and j we create a new column. So our dataset now looks something like this. We will have many columns, right? So let us just go back. Our data set looks something like this, 161. So we have many columns. How do we get those columns? By multiplying. Suppose these are our x1, x2. So we are multiplying, let's say x1, x2, and then x1, x3, and then x1, x4. We are taking all possible combination. We are using these double for loop. So we are multiplying basically everything. So we obtain something like this. Now we have a higher degree polynomial, isn't it? So what we do basically now is x2, whatever we did with xtrain 1, xtrain 2, now we do with xtrain 2 another variable. Now we do the train test split of from a scalar dot model selection. These things you all know well already. So if we see the shape of our database, it is row cross column would look something like this. And then if we try to compare our accuracy score one-on-one with our previous linear regression, we find earlier it was only 66%. This is object 1. Remember that this is our object 2 handle with which we are fitting our xtrain 2 and ytrain 2, which is basically our polynomial regression output. And object 1 dot score is was just 66% on the Boston dataset, and object 2 dot score has now turned out to be 82.4%. Now you will see if we did a nested for loop of I in range, for j in range. Suppose we have done 3 nested for loops, then we have got a 3-degree polynomial. For every features we have got a higher dimensional 3-degree polynomial, so our accuracy would have increased further. In this way we can increase and increase and increase our accuracy, but remember that could lead to overfitting of the model. And you already know those bias versus variance trade-off. I've already explained in my previous videos. Those trade-off must be taken well care of while handling these things. So this is all. Yeah, thanks a lot. Next video we will understand about stochastic gradient descent, about the various gradient descent, batch gradient descent, and how it works, basically what is the code for it, and n feature gradient descent, everything we are gonna see. So yeah, that's all from this video. Thanks a lot.